One of the strategies to improve I/O performance of Node apps is caching. Caching frequently used data in memory can reduce the number of I/O operations needed, improving performance. Various caching strategies can be employed, such as in-memory caching, cache-side proxies, and read-through proxies. By storing data that is often requested, your app can bypass slower I/O operations, leading to faster response times. Another technique is using a faster file system, such as memory-mapped files, which can improve I/O performance by reducing disk access time. By mapping files directly into memory, you minimize the latency associated with traditional disk I/O operations. Next is connection pooling. Managing a pool of open database connections can significantly reduce the overhead of repeatedly creating and closing connections, thereby improving performance. It's a best practice to keep a connection to the database open throughout the operation of the application, which minimizes the latency involved in establishing new connections. Then there's multiprocessing. Using child processes or worker threads can improve performance by enabling tasks to be executed in parallel. In Node.js, the cluster module allows you to spawn multiple child processes that share the same server port, effectively increasing its computational power of your application. These processes run their own Node.js instances, and the built-in load balancer distributes incoming requests to them. Additionally, the cluster module handles worker lifecycle tasks such as graceful shutdowns and auto restarts. However, while the built-in cluster module is useful, it may not be the preferred choice for managing nodes processes in a production environment due to its basic nature and lack of advanced features. Instead, process managers like PM2 are commonly used, but more on that later. Next strategy is optimizing database queries, which can greatly improve I/O performance. Techniques like using indexes and materialized views can reduce the time it takes to retrieve data, minimizing the impact on I/O performance. Using streams to handle large datasets can improve performance by reducing memory usage and processing data in chunks. Streams allow you to process data as it is being received, rather than waiting for the entire dataset to be available, leading to more efficient memory and I/O management. There's actually a whole section in this course specifically devoted to streams, so be sure to check that out. Lastly, microservices. Implementing microservices can enhance performance by breaking down a monolithic application into smaller, more manageable services. However, it's important to note that microservices introduce network latency in response times and increase the overall complexity of the system, sometimes very. The trade-off between performance gains and increased system complexity should be therefore carefully considered.